Good afternoon, everyone. This is Harrison, Dan, and I'm Jacob, and today we're looking at an investigation into myeloma. So our patient is Max Manley. He's a 42-year-old ward worker. Initially, Max complained that he felt overly fatigued, felt ache in his bones, and noticed that he had the discoloration of his urine when he urinated on hostile pylons. While he was working, Max had an injury where he fell and he immediately needed to be evacuated to the hospital by helicopter. And upon presentations, his clinical presentations was fatigue, achy bones, and anemia. His laboratory findings found that he had serum phosphate above reference range. His urine sample was total protein method was negative. Total proteins by precipitation method did, however, show protein. Leukocyte differential was within reference range, and total red cell count, total white cell, and red and platelet cell counts were below reference range. His erythrocyte sedimentation rate was above reference range, and his beta-2 microglobulin levels were above reference range. Bone marrow aspirate was obtained and showed increased number of plasma cells.
Yep, so based off the symptoms Max Manley presents with, there could be a preliminary diagnosis made. To make the correct diagnosis and rule out any differential, the laboratory performed a series of tests. So blood urine and a bone marrow aspirate were obtained for analysis. This was followed by 6 tests necessary to accurately diagnose Max Manley: serum protein electrophoresis, radioimmunodiffusion assay, serum calcium, serum albumin levels, and his serum hemoglobin was assessed.
Yep. So so indicators for requesting serum protein electrophoresis. So Max did have elevated erythrocyte sedimentation rate, unexplained anemia, and presence of proteins in his urine. So in the serum electrophoresis, the serum protein electrophoresis is a means of separating proteins based on their electric charge and their weight. Bands are broken up So the bands are broken up, categorizes them into 5 bands: the total protein, albumin, alpha 1, alpha 2, beta, and gamma. Total protein and albumin. Total protein tells you the total amount of protein in the sample. And in this case, with Max, he had elevated globulin levels, which we find in the gamma region. So Max's sample, showed quite distinct band in the gamma region. Slight protein increases in the alpha and beta bands, strong protein increases in the gamma band, indicating high levels of immunoglobulins. Findings consistent with multiple myeloma but not definitive. There are differential diagnoses that show the same characteristics, such as lymphomas, Waldenstrom's, macroglobulinemia, amyloidosis, and plasmacytoma. And to find out what type of immunoglobulin we have, because in multiple myeloma you can have IgG, IgA, IgD. In Waldenstrom's macroglobulinemia, it's only IgM, and our serum SPE doesn't tell us what type it is. So we perform another test, immunofixation, to determine what type of band that is.
So the urine dipstick wasn't able to detect the Jones proteins So this immunofixation electrophoresis was conducted in part with the SPE, so we can determine the specific immunoglobulins present. So with our results here, we can see that there's a distinctive band in the heavy chain G, which would be this large part of the antibody, as well as free light chain kappa free light chains, which make up this part, which would not have reacted with the urine dipstick testing. So with that, with this presence of the free kappa light chains, that is our Bence-Jones protein. It helps us narrow down. It helped narrow down the diagnosis into multiple myeloma, and in conjunction with this test, radial diffusion was then performed to figure out the concentration of this immunoglobulins.
Yep, so a radial immunodiffusion assay was performed. So we had high calibrated, medium, and a low. Then we also had Max Bainey's sample. Now we used this immunoglobulin sample to with known concentrations and his unknown concentration, and then plot a straight line, and then use his unknown concentration to plot it and get a rough estimate of his concentration. But due to some unknown error in the laboratory, the test is unfortunately inconclusive. It shows he has a low concentration of 6.373 and a high. So then next we tested Max's hemoglobin levels as total symptom codes in the sympathy and indicative of anemia.
So we did a hemoglobin estimation. So hemoglobin is a major oxygen carrying component of red blood cells, and is important for diagnosing anemia and other blood disorders. Max's hemoglobin was collected from whole anticoagulated blood. It was analysed by spectrophotometry using the cyanoglobulin method at 540 nanometers. Max's hemoglobin was below reference range at 114.4 grams per litre, and we also used for control and for accuracy and gradients and a reference range for a normal adult male.
So the next test we ran was his serum calcium. In a healthy state, there's an inverse relationship of calcium and phosphate. The parathyroid hormone regulates calcium and phosphate by activating osteoclasts, which release calcium, phosphate, and hydroxyproline from bone stores in response to low serum calcium concentration. So the kidneys increase calcium concentration, absorption, and decrease phosphate reabsorption, which increases calcium in the blood and excretes excess phosphate into the urine. As calcium levels rise, a negative feedback loop reduces the level of parathyroid hormone from the parathyroid gland. However, multiple myeloma has the ability to secrete parathyroid hormone-related peptide, which constitutively activates osteoclasts and results in hypercalcemia. Hyperphosphatemia indicates reduced glomerular filtration rate and renal impairment, which can be an indicator of disease progression. Max suffered femur fracture, likely from bone resorption. The new plastic cells mediate bone destruction and can inhibit bone remodeling. Multiple myeloma-derived factors will upregulate the expression of NF-kappa beta ligand and bone marrow stromal cells that activate osteoclasts.
Max's serum albumin levels were then tested due to a lack of reaction for his albumin with the urine dipstick. The serum levels were tested. The test was conducted using a biochemical green detection for the albumin, and Max's serum albumin levels was significantly below what we would consider the healthy range for an adult male, and this is most likely due to the liver reducing albumin levels to maintain the osmotic pressure within the blood vessels due to the buildup of these detected bench-Jones proteins and immunoglobulins, as well as inflammatory proteins. And this poses quite a large problem for the body because albumin acts as a very key transporter, transporting calcium as well as a variety of hormones, steroidal and lipophilic hormones throughout the body. So the reduction of this has a very wide range of effects on MAX. And after this testing, ESR testing was then performed on MAX for the sedimentation rates of his blood.
So it's a simple test, a blood test used to determine inflammation levels in the body. It measures how quickly red blood cells fall to the bottom. So in this instance, it's a test tube, over 60-minute administration. So as you can see, his sedimentation rate is 100 millimeters per hour. Rapid change from adult male is 1 to 10 millimeters per hour. It's a reflection on the zeta potential, a measurement of RBC to RBC interaction that causes them to repel each other. So in a normal healthy volunteer, this is a general confirmation of red blood cells, and Max mainly that is bond together formation.
So there are secondary complications with with multiple myeloma. So you can have renal insufficiency. So the presence of bench-Jones proteins called from myeloid cells can actually deposit themselves into the distal convoluted tubules, and they can actually impact transport mechanisms involved in regulating blood plasma, electrolyte balances and stuff like that. And damage to those areas can also, well, the kidney has a lot of important functions. They regulate a lot of hormones, responses, manipulate blood pressure. It also secretes erythropoietin, which is a stimulator of red blood cells in the marrow. So further testing would be required to determine the level of renal function, and you would need to do a creatine. So by measuring the GFR, the glomerular filtration rate, it cannot be detected directly. Instead, we measure creatine clearance to estimate it.
So to surmise, with these, Max was presented with his major first symptom that he noticed was the urine color changing when coming into contact with hot pylons. He had strange dizziness, people observed him being unusually pale, and ultimately he fell breaking his femur, which is quite unusual for someone with healthy bones. And due to this, when he arrived, we performed tests for serum protein electrophoresis, so we could determine the general range and of expressions of proteins. It resulted in a high gamma band expression, high albumin expression. Following this, immunofixation was performed so that way we could determine more specifically what kind of immunoglobulins, heavy chain and light chain, was present from the SPE results. And hematocrit and blood cell counts were performed so that way we could determine the cause of his dizziness and pale complexion was most likely due to his anemia, which that kind of, and the hematocrit and blood cell counts would have been lowered due to the bone degradation. So, and that leads into the calcium tests. This hypocalcemia can be explained by bone reabsorption, which also explains the low blood levels and the easily broken femur. And with these joined together, with all of these tests joined together, we and the indicator of the phosphate showing possible indicator of kidney deficiency, as well as the beta-2 microglobulin, which tested above which is used as a tumor marker. We came to the definitive conclusion of Max having a later stage multiple myeloma, and with that, there is no cure for that. So Max, we began treatment of it with chemotherapies and radiation, the possibility of bone marrow transplants, but there is no cure for multiple myeloma, and the best hope is to extend Max's life, but there will ultimately be no cure for that.
Very good, guys. Thank you. Questions from the audience?
Well, I have a couple questions to get started. Can you just recap what multiple myeloma is really briefly? What is it?
It's a cancer of the plasma cells, B cells. So they proliferate and produce paraproteins of the immunotype, which makes a defective immunoglobulin.
It's like a monoclonal gammopathy.
So there's no function of one type of.
And it's outcrowding within the bone marrow. All the other antibodies you expect to help immune function. So there's going to be immunosuppression because there's just overproliferation of just one.
Also, it's outcrowding things like neurons and cells and whatnot.
Yeah, so there's a lot of confidence. So because it's a massive increase in just those one type of cells, it drowns out any other functional immunoglobulins, which makes them susceptible to high infections. It also obstructs new construction of red blood cells, which is also a result of the anemia and low hemoglobin levels. So there's less blood cells and there's less hemoglobin, less oxygen delivery.
What else does that link to? One of the other biomechanisms as you're looking at carrying out in the bone marrow?
Oh, yep. So the albumin test. Oh, calcium. Yeah. No, yeah. So there's the increase in calcium because there's increased osteolytic activity. So resorption of bone bones being broken down, and hormones like parathyroid hormone would usually regulate that. But because of these myeloma plasma cells, they actually can secrete their own parathyroid hormone related peptide that can actually stimulate it, and some of the other cells can also, some other substances that those cells release can actually also inhibit the osteoblasts from. Interleukin 6 is an inflammatory cytokine that, of course, is also stimulating that.
Yes. So I'm going to ask you about some of your results. Can you go back a couple slides, if that's okay? So we'll start with your RID, the one that didn't work. So this one. So my first question is your control of marriage? So you said we can't accept the patient because it's lower than what you expected, which is okay. But is your control of marriage is the first question I have. So it's 49, that's correct. Was that in range for your assay?
Okay, yep, so there hasn't been inclusion of control range on this slide.
Do you not from
It wasn't within the range. The controls weren't within range, so that we weren't able to make a proper deduction from his results either because the control wasn't in range to use as a reference against it.
So the control concentration is supposed to be 14,000. And why is there a floating of 49 on your line of best fit? And why is your line of best fit not a line of best fit?
That's where I was going with this. So it's not a line of best fit, and it's.
Because if you were to make that a line of best fit, and then if it's 49, you're saying, I feel like that would be close to 15, and I wouldn't necessarily exclude that as a result. Because they would give it a range, you're given a concentration that you should be close to about 14,000. Just over 15 isn't necessarily that much.
Yeah, so if you're saying that it's at 49, so then we go into where it is on the curve, that's sitting at 15,000, that's potentially within range. Anyway, what my question for you actually was the patient sample diluted?
So 1 and 2 dilution.
Yes, have you doubled it?
The concentration.
So you've got 26, have you doubled that? I.e., is your number actually 50 and high?
Yeah,
Or
I'd
medium?
have to look at the data.
I just, more to help you along with your report, I have a feeling that your data's actually completely fine here. You're interpreting it wrong.
Yeah,
Just to-
I think originally when we were looking at our root experiment, we did have there was a difference in one of the bands,
Yeah.
which wasn't supposed to be like that. So that's kind of made
So if you have triple
inclusive.
kids,
Yeah.
you are more than welcome to take one out
Can you
if it's an
exclude
outlier.
one if there's an outlier? Yeah, that's fine.
If you make your line of test fit an actual line of test fit and follow where the control is, you should, I think maxes should be above the reference range, which is what, you haven't actually got any concentrations on this page.
Yeah, so that's why I sort of brought this up, because that's the line of best fit. I actually think your control is within range, and if you double the sample, it would actually be medium to high, which is the result that you'll see
Probably
over
the control, the normal range.
expecting.
Okay,
So I just wanted to help a bit with the results, because I think there was just an issue with some result interpretation. Can you also go to the hemoglobin? Yeah. What's the control range? So you've accepted Max Manley's result as below reference range. What's your control range? It was your assay in range.
It was in range. I can't recall the control range off the top of my head, but we did check it.
That's cool. Otherwise, having a control is somewhat redundant if you're
Yeah.
not telling me that it's in range at all. And the rest of the assay, we can't sort of accept the results if we don't know that there's a control range.
Also having it sitting above the reference range, like that implies that you're using the reference.
Yeah.
Yeah, and then that would tell me that's out.
Yeah, that up, yeah.
So just be really careful with how you're presenting results. I have one more question about the IgG kappa, G kappa thing, this. Why do you have a white lambda there? It could be an experimental error, just asking
Yeah,
a
well,
question. Okay,
they-
okay, I'm just asking a question. I just wrote things down and it was fine.
We did have a lot of laboratory errors.
Okay,
It could have
it's
been.
fine, that's
No,
fine.
it's not your fault, I just didn't want to go, it's not your fault, but everyone had it, so don't worry about it.
Yeah.
What is it?
So,
Why is that? Is the tube?
The tube is on that anyway.
Yeah,
Yeah.
there's a normal healthy ratio of kappa to lambda ratio.
So it is, isn't it?
So it would be.
You have an excess of kappas. but
Yeah.
Some lambda, the cell is going.
Yeah, that's, you know, you can talk about that as well in your report, your reporting results, so.
The last point with this slide actually is when, you guys pretty much jumped on and were like, free light studies. But this, I wanted to point out, is not going to tell you whether or not these are free or not. That was more from your, urine electrophoresis and your precipitation methods. Yeah. They can't determine, no, it's not telling you if those are free or if those are bound to heavy change, or if they're bound to heavy change or not bound to change process. Just be careful.
Okay.
Yeah.
I wanted just to ask you again about your the staging of the multiple myeloma. You said that you suggested it was late stage, and what's that basis of? What's that based on?
I did have a source for it, but it's, I didn't have, well, compared to the first group, I never found a complete breakdown for that. I just found a sort of general, in my source of.
So what do you mean by late stage?
As in the disease has it's already begun its progression, so this isn't a new development, it's already been this way for a while and it's started to move through the body.
And I think is it also got the basal microglobin level indicates the extent and proliferation of the plasmoid cells, but also the phosphate, the high phosphate levels as well. It's high phosphate levels that aren't being excreted by the kidneys, because at that where they usually taken up out to be passed out by urine, that's not happening because there is damage from the downstream proteins.
So you have to look at what the stages were and what would dictate
I wasn't, in the source I found for prognosis, is it wasn't that detailed, it just kind of gave a general at the beginning versus.
Just one question. You touched a little bit on that when you answered one of the questions. One of the queries that we wanted you to elaborate was the reason why this person might run into pathogenic infections. What is the reason for that?
So I'll take it. With the proliferation of IgG, you're going to have it's going to be overwhelming. You're going to be immunosuppressed from this proliferation as well as the bone breakdown. That's where a lot of your other immunoglobulins as well as innate immune system come from and are developed sort of without that being intact. That those systems are compromised and either aren't working at all or only working at a lower rate, so you're going to end up with these greater bacterial infections.
There's one very specific reason why that might be the case. You might not have come across that, but the fact that you have only one type of immunoglobulin being produced, how do you link that together with pathogenic infections?
So with only one type, your range of defense is going to be much lower because if you've only got IgG, it's only ever going to react to the type of bacteria and viruses that it can react to, versus if you had that broader range with IgM and IgA, then you can react to the things that IgG can't.
It's a little beyond that, because that when mentioning an excess of IgG is probably a useless IgG from that point of view, because it's coming from a particular clone and the specificity is likely
It's
to be
a
useless.
cancerous clone.
So it is occupying the space of the immunoglobulins with something that is not healthy.
Yeah.
All right. Thank you very much, guys.
Hey. Stay right there.
Oh, sorry.
Just give you some feedback.
Look back and it feels like.
That was congratulating because we choked. It's all over. No, thank you so much for that. A few points I really quite liked. How the slides were going. They could have been a little bit better in terms of the space they were using. I think that the information you had was reasonable. I think it was reasonable. It was just a little bit off from being less perfect in terms of just making use of the space and the figures that you used. So it was not bad at all. I also quite liked the flow and the order you guys chose. I thought that it was quite easy to follow. There was a lot of information on some of these slides, in particular the first slide, even with the background about Max, maybe we could have highlighted the important parts, your fracture, the urination, the steel pylons, just bringing our attention to a couple of things, because you don't have to read out the entire thing. You could show that this is some background and these are the important points you need to think about when moving forward here. But apart from that, you guys answered the questions well. I think that you don't know what you're talking about. Maybe missed a couple of things when you were talking, but that's just there. You'll get that. But you had a chance to kind of do something. Did a good job.
Yes, so.
Good job, guys. I mean, you did a good attempt. I reckon there's too much text on a lot of the slides, and that's something you should work on. Also, speaking to the slides, often that you might be reading off the slides afterwards, or even reading your notes instead of just highlighting important book in some cases. So that's just something to work on. A bit clunky at times, but you got there in the end, and most of the stuff you put in is something that wasn't too bad. Just be aware of that. I think with a bit more practice that would have been good. But my main criticism was too much information on too much text on the slides.
So it's kind of is it disagree on here now?
Sometimes it's there because it's sort of wanting to safety net for you, but just be aware of that. That's what I'm trying to make with regards to that. I mean, pretty much just got stated in time, which is good. And I think we covered most of the areas with a little bit of allusion from the questions.
I had similar comments. Often you had a lot of text that you didn't use, so you had, and then you don't need it. So if you're not going to speak to whatever is in the slide, then you can use it. It's just distracting. And you copy paste the case study, for example, which you didn't use. So at the beginning, when you presented it, and in several instances, there was just a lot of information that you didn't use, and it looked like it was needed. So you could use better the space for things that you're going to use. Several of the figures were not cited, so for the references, so you should be more consistent with that. On the gel, on the protein gel, you had a lot of members in the actual protein gel. No, it's further back. Back. That one there. I don't know what that means.
So this was just describing like where different bands are.
What do these numbers mean? What are they?
Oh, so it's just kind of a, well, I suppose it'd need further labeling, so you could have, it would say total protein, it would say allergen, it would say.
So my point is,
it's essentially like this, but with the visualization of an actual gel. So it's, you want to get what I'm saying?
yeah, so the point to me is either it's useful and helpful and then you explain it, and then you tell us what the numbers are and whatever. I suspect in this case it's not necessary to get into that much detail and it is distracting. So you need to choose. So either you want to talk about it and then you do and then explain to us every stuff, every element of the figure that is there, or just ignore and don't put that much detail because it is distracting. So again, it's the same issue with the writing. So those writing up there on the top on the green, I, in my very blind aging eyes, can't read that.
Yeah, that shouldn't be there.
And
We made some late additions this morning, which shouldn't
so
really
it's
happen.
so again, prioritize what you want to show. Mainly is what you're going to talk about. Lots of the stuff that is written in that particular slide, for example, you didn't mention, and it won't help in your presentation, but just gets distracted. Again, it was pointed out some of the explanations on the diagrams were unclear. I couldn't follow the explanation on the IA, for example. That was really complicated for me to follow. I would have liked to have a better discussion or explanation on the. So you mentioned some hormones that came out to explain the levels of calcium and phosphate. That would have been helpful if you had some. So you talked about the hormone. I think it was the PDH or something you mentioned. You mentioned that on your speech. It wasn't something written on the slide. So again, I think a better correlation between what you write in your slide, what you put on the slide, and what you talk is better for the audience. Because sometimes you, speaking about things that were not in the slide, or had a lot of stuff in the slides that you didn't talk about, that disconnection is distracting. I thought the albumin data was well explained. That's a good example of something you did well in terms of how the data came out and when that comes from, where the origin of that levels were well explained. So I think overall there was the knowledge behind, but perhaps the way it was presented could be improved. That's what I have.
Jump in. I think the first sort of few result slides that you went through them really quickly, and as Alejandro was saying, it wasn't sort of like I could follow some text as you were explaining things because you just had way too much text on the slide, and it's in quite a small font that you can't really see. I think there are a few issues with explaining some of the results. So again, double check that RID because I reckon it's going to be fine. So double check that. So just making sure that you understand each result and what it means towards the diagnosis. I think just understanding a bit more about what test was done and why will help, particularly when you're putting your reports together, and understanding what the control range is used for, why it's important to talk about. But yeah, I think some of the results were just gone through a little bit quickly, and some of the questions weren't touched in depth quite enough. But when we asked you questions, you could answer anything. So you obviously do know the information. It's probably just putting the talk together that.
Yeah, I think when I started, there was a lot that I was supposed to say that I didn't. That would have linked some of the stuff.
That happens, that's normal, but you guys obviously know what you're talking about when we ask questions, so that was clear. Yeah, thank you.
Right, guys, thank you very much for your contribution. That was very, very